Hello everyone. Today I am going to discuss about Boyce-Codd Normal Form. Okay, what is meant by Boyce-Codd Normal Form? Given examples of Boyce-Codd Normal Form. Before going to the Boyce-Codd Normal Form, in last classes, and what is meant by first normal form, and what is meant by second normal form, and what is meant by third normal form, and then followed by that is a BCNF. Clear? First normal form states that only simple or individual or atomic values, there is no multivalued attributes, is nothing but first normal form. Second normal form. Second normal form states that a relation schema R is in the second normal form for every non-key attribute is fully functionally dependent on primary key, is nothing but second normal form. Second normal form drawback is the partial dependency. Partial dependency. That is a no partial dependency in second normal form. That is a drawback. And whereas a third normal form, a relation schema R is in the third normal form, extends to A holds. Extends to A holds. Either X is a key, the key like super key or foreign key, primary key, whatever it may be, that is a, keep in your mind, that is a key. Either X is a key or A should be prime attribute or key attribute, is nothing but third normal form. What is the drawback in third normal form? No transitive dependency. No transitive dependency. No transitive dependency. Right. Next, that is a Boyce-Codd normal form. What is meant by BCNF? A relation schema. A relation schema R is in BCNF, extends to A holds, X must and should, that is a key. X must and should a key, that is a super key or primary key or candidate key. Clear? That is a definition, Boyce-Codd normal form. What is the difference between 3NF and BCNF? 3NF and BCNF. Right, 3NF definition. First one is a definition. What is the definition? A relation schema R is in the third normal form, extends to A holds. Either X is a key or A should be prime attribute, is nothing but third normal form. Whereas in the Boyce-Codd normal form, a relation schema R is in the BCNF, extends to A holds, X compulsory key, is nothing but that is the BCNF. For example, BCNF R of AB. Relation is the AB. A tends to B. A tends to B. Is it what normal form? Suppose that is the first one, A closer. A closer. You can get the original relation AB. Can get the original relation AB. That is a is a key. That is a is a candidate key or a key. Candidate key. Right. Observe here. Is there any partial dependency? No. Is there any transitive dependency? No. Okay. It should be simple or individual or atomic value. Why? Because simple relation. Why? A is a key. Why? Because functional dependency property. A tends to B. B is dependent on A. A determinant. B is the dependent. That's why that is a B subset are equal to A. Functional dependency property. That's why the given normal form is the Boyce-Codd normal form. BCNF. The given normal form, Boyce-Codd normal form. That is a simple example of BCNF. All left hand side must and should be key, is nothing but that is a Boyce-Codd normal form. That is the first definition of 3NF, definition of BCNF. Example, that is the second one is a example. Example is a R of ABC. AB tends to C. C tends to A is an example of third normal form. Functional dependencies AB tends to C. C tends to A. Observe here what is the candidate keys AB closer. AB closer is the A, B, C. C closer, CA. That's why AB is a key. That is a C is not a key. Okay, and what is here? I mean candidate key equal to AB. I mean non-key attribute equal to C. Okay, observe here according to our definition. What is the definition? States that AB tends to C. Either X is a key or A should be prime attribute or key attribute. AB is a candidate key, right? No doubt about it according to our definition. Left hand side satisfied. What about C? C is a non-key attribute. Okay, but according to our definition, either X is a key, either that is a here, this is X and this is Y. Either X is a key, the condition is satisfied. And then C tends to A. C is not a key, but A is the key attribute. Here candidate key equal to AB and then key attribute or prime attribute equal to A comma B. That's why the relation R is in the third normal form. What is the third normal form? R of A comma B comma C. AB tends to C, C tends to A. First we find closure. That is a AB closure. A, B, C. We can get the original relation. That's why AB is a candidate key. You need not bother about. That is the here keep in your mind key or primary key or candidate key. That is the AB is a candidate key. That is the key attributes A comma B. Prime attributes, key attributes are also called as prime attributes A comma B. A comma B. According to our definition, left hand side, that is observe here, either X is a key or A should be prime attribute. Okay, that's why AB is a key, C is not a key attribute. Here C is not a key attribute, but A is a key attribute. That's why the definition is satisfied. That is a relation R is in the third normal form. Definition example. Whereas in the BCNF example, observe here BCNF example. Functional dependency F equal to A tends to B, AB tends to C, ABC tends to D, ABCD tends to E. These four all functional dependencies. Clear? According to our definition, what is the definition? Boyce-Codd normal form. A relation schema R is in Boyce-Codd normal form. X tends to A holds. X must and should key. That is a primary key or super key. Okay, that is why left hand side of all productions, of all functional dependencies, must and should key according to our definition. Observe here, a functional dependency F equal to A tends to B, AB tends to C, ABC tends to D, ABCD tends to E. First we find closure, A derives what? B. That is the AB. AB derives what? C. ABC derives what? D. I mean ABCD derives what? E. We can get the original relation. That's why A is a key. And then ABC closure. ABC derive D. ABCD derive E. We can get the original relation. ABC also a key. Okay, and then next one ABCD closure. That is equal to ABCDE. Okay, we can get the original relation. All left hand side, A closure, AB closure. Okay, A closure, AB closure. What is the AB closure? AB closure, AB derives C, ABC derives D, ABCD derives D. A closure, ABC closure, AB closure, ABCD closure. You can get the original relation. All left hand side are keys. No doubt about it. It is in Boyce-Codd normal form, BCNF. It is in Boyce-Codd normal form. What is the definition? A relation schema R is in Boyce-Codd normal form. X tends to A holds. X compulsory must and should key is nothing but BCNF. That is the first example. Okay, that is the, first one satisfied, second one example, third one difference between, 3NF and BCNF. A relation schema R is in 3NF, but not necessary in BCNF. Whereas in the, right hand side BCNF, a relation schema R is in BCNF, a relation schema R is in BCNF is also in 3NF. That is a major difference between the 3NF and BCNF. Third point plays a very important role. What is a relation schema R is in Boyce-Codd normal form is also in 3NF. A relation schema R is in third normal form but not necessary in Boyce-Codd normal form. That is BCNF. What is the difference between 3NF and BCNF? Observe here one more example, that is a functional R of A, B, C, functional dependency AB tends to C, BC tends to A, AC tends to B. First we find that is a closure, AB closure, AB closure, and then AB closure you can get AB, AB derives what? C, and then BC derives what? A, and then what is here? AC derives what? B. You can get the original relation. That's why AB is a key or candidate key, whatever it may be. That is a key. You need not bother about that is a key or candidate key. Okay, that is a candidate key AB. And then next BC closure. BC closure, BC, A. You can get the original relation. AB is a key, BC also key, and then AC closure. AC closure, AC derives what? B. You can get the original relation, that is by using the closure property. AB, BC, AC all are the keys, all are left hand side. That is the left hand side of all functional dependencies are key. No doubt about it. What is that normal form? It is in Boyce-Codd normal form. It is in Boyce-Codd normal form. In gate point of view, plays a very important role. Okay, is it what normal form? May ask like that only. Is it what normal form? Is it 1NF? Is it 2NF? Is it 3NF? Is it BCNF? 1NF is the only simple or individual or atomic value. There is no multi-valid attributes. Okay, a table, the given table. Okay, that is suppose for example student table having student name, student number, marks, address. Student number is a primary key uniquely identified within the entity set. The table is in first normal form. There is no multi-valid attributes. Whereas in the second normal form, no partial dependency. But according to our definition, for every non-key attribute is fully functionally dependent on primary key. That is the second normal form. Third normal form, a relation schema R is in the third normal form, extends to A holds either X is a key or A should be prime attribute or key attribute. You need not bother about what is a prime attribute, what is my key attribute. Suppose candidate key is equal to AB. Key attribute equal to A comma B. Prime attribute is equal to A comma B. Okay, either X is a key or A should be prime attribute. That is a third normal form definition. There is no transitive dependency. What is by transitive dependency? I think you are familiar that X tends to Y and Y tends to Z. Y tends to Z. It is a transitive dependency. Remove transitive dependency in third normal form. Whereas in the Boyce-Codd normal form, a relation schema R is in the BCNF, extends to A holds X must and should super key or primary key. All left hand side of functional dependencies is a keys. Okay, not right hand side, all left hand side. That is a Boyce-Codd normal form. A relation schema R is in BCNF is also in 3NF. A relation schema R is in 3NF but not necessary in BCNF. That is the difference between 3NF and BCNF. Right, observe the gate 1998 simple bit. Which normal form is considered adequate for normal relational database design? Okay, relational database design. I think relational database design, that is a ER model, how it can convert ER model to table. Okay, in generalized business oriented system, we use that is a 3NF. This is a standard bit, third normal form. Clear? Right, observe the next bit. Gate 2012. Which one of the following is true? Observe the first one. Every relation is 2NF is also in BCNF. No. Why? Because every relation is 2NF is in 1NF only. That is why this is false statement. A relation R is in 3NF if every non-prime attribute of R is fully functionally dependent on every key of R. This is second one also false statement. Why? Because not 3NF but here a relation R is in 2NF if every non-prime attribute of R fully functionally dependent on primary key. That's why that is the second bit also false. Third one, every relation in BCNF is also in 3NF. Already told that. Okay, a relation R is in 3NF is also in a relation R in BCNF is also in 3NF. That's why third bit is the true. Every relation in BCNF is also in 3NF. Why? Because observe here, every relation 3NF but not necessary in BCNF, but every relation in BCNF is also in third normal form. A relation R is in 3NF is also in a relation R in BCNF is also in 3NF, is also in 2NF, is also in 1NF. Right. The last one, no relation can be both BCNF and BCNF and 3NF. No, this is also false. No relation can be in both BCNF and 3NF. Okay, that is the correct option, is the third option. Every relation is BCNF is also in 3NF. Plays a very important role. That is the difference between 3NF and BCNF. Okay. Right. Next, practice of example. Get examples. R of A, B, C, D. Functional dependencies is equal to A tends to B, B tends to C, C tends to D. What is the first step? Keep in your mind. First, we find closure. Why you can find the closure? Okay, you can identify the keys. Okay, when you identify the keys, we can easily, which is the which normal form? Forming a table. Right? Observe here. A tends to B, B tends to C, C tends to D. First one, A closure. A closure. A derives what? B. Right? B derives what? C. C derives what? D. That's why A is a key. Right? Next one, B closure. B closure. What is a B, C, D? B is not a key. C closure. C, D. C is not a key. Why? Because we can't get the original relation. We miss here A, we miss AB. Okay, that's why A is the key. Okay, what is the first normal form? We check one by one according to our normalization techniques. What is the first normal form? That is A is a key. A is a key. That's why no doubt about it. There is no repeating groups. There is no multivalid attributes. That's why it is in first normal form. First normal form satisfied. Second one. Second normal form. What is the second normal form? There is no partial dependency. Here there is no partial dependency. And what is my third normal form? A relation schema R is in the third normal form. Extends to A holds. Either X is a key or A should be prime attribute. But what is the main drawback of third normal form? Trans to dependency. Observe here, A tends to B, B tends to C. Trans to dependency is there. B tends to C, C tends to D. Trans to dependency is there. That's why it is not in third normal form. It is not in third normal form. Third normal form violates. That's why it is in second normal form. Second normal form. Up to 2NF is satisfied. Clear? That is the first bit. Second bit. R of A, B, C, R of A, B, C, functional dependency A, B tends to C, B tends to C. Is it what normal form? Is it first normal form? Is it second normal form? Is it third normal form? None of the above. Observe here, what is the first step? Closure. We find that is a key. That is a AB closure. AB closure, A, B, C. We can get the original relation. That is a candidate key or key. Candidate key equal to AB. Key attribute. Key attribute equal to A, B. Or prime attribute equal to A, B. Next one, B closure. B closure. What is a B closure? B, C. B is not a key. Observe here, and what is it 1NF? 1NF is satisfied. Why? Because AB, the given table is the key is there. That's why 1NF is satisfied. Whereas the second normal form, observe here second normal form. What is the second normal form drawback? Partial dependency. AB is a key, but B is the part of the key. That's why B is the part of the key. Here it violates the partial dependency. Okay, what is that? It is in what? First normal form. It is in first normal form. Why? Because it violates the second normal form. That's why C is wrong, B is wrong, and what is the correct answer is the first normal form. Okay, today what is that? Boyce-Codd normal form. What is in my Boyce-Codd normal form? What is the difference between BCNF and 3NF? I hope you everything is able to understand. In next class, and what is in by dependency preserving. Okay, simple examples of dependency preserving that we will see in the next class. Thank you.